The first thing is we are going to have community announcements going forward. Things like we are hiring Rust developers, which is actually true. I work for Braid, and we are, in fact, hiring Rust developers. So if you're interested in learning about what we do, come and talk to us. There's a lot of us here from Braid. For example, the person who's going to present tonight, Sean, also works at Braid. Cool. So these couple of small things that I mentioned. My name is Matej Kovac. Very nice to meet you all. I work at Braid. The presentation is going to be recorded. If you don't want your face to appear, please come and talk to me. After the talk, we are going to have free pizza, and there's also free beer in the corner diagonally opposite to me. And if you're not in a rush, after we're done with the talk and hanging out, finished all the pizza, please stay with us a little bit and help us reorganize this place because we need to return it to its original state, moving the tables and the chairs, so on and so forth. And special thanks to Braid for helping us organize this Rust meetup. Our presenter tonight is Sean Payne, who's a good friend of mine. Please give him a big round of applause.
Thank you very much. Just 1 second here. Oh, I don't want you guys seeing this yet. That's not cool. Oh no. Go away. I want to hide all of this. Okay. Now, let's see. Okay. What did you say? We'll full screen this?
F11.
F11. Oh. There we go. Okay. So, today we're going to be talking about property testing. And I've come up with this very original slogan, which is make testing great again, because I don't like testing. All right, so just to give you a quick introduction, my name is Sean Payne. As Matej said, I do work with him at Braid. I had kind of one of the weirdest paths to get into coding. I started about 10 years ago when I was in college, and I worked in sales at Tesla Motors while I was there, worked as an intern in the compliance department doing really boring stuff at AWS. I've worked for some digital marketing startups. I was a professional actor in Los Angeles, worked for Audify here in Tokyo, and then finally landed at Braid. So, how many of you guys feel a bit like this when you hear the word unit testing? I've got at least a few honest people in the room, which is good. So, for me personally, I don't really like to write unit tests. I find them to not be very fun, and a lot of the time my stuff will still break, and I'll learn that I haven't properly tested. So, when we talk about unit testing, what we're really talking about is classical testing, which is handpicking some inputs and outputs and seeing whether or not our function works for those. Can anybody think of any downsides to this approach? Yes? You might forget to cover some case. Yeah, absolutely. Yes? It is time consuming, and so it makes you lazy. I completely agree. And not only is it time consuming, but you're basically doing a lot of the boilerplate code over and over again, maybe creating lists, populating them, something like that. So definitely. Cool. Yeah, so this is the idea, right? It's incomplete. You pick some things, maybe you forget something, and even though you've got all these great working cases, your ship sinks. You might also just implement one of them wrong because you have to do a lot of the boilerplate code. And it's labor intensive. So when we talk about testing today, we're going to be thinking about two concepts mainly. One is that things are correct. So if we have an input and we have an expected output, we want our actual output to match that, right? And the second idea is that it should be complete. And what I mean by complete is that it should work for all of our input-output pairs that we could possibly generate for our function. A lot of the time in unit testing, even if we cover a lot of edge cases, there's still tons of things that we're not really testing. We just assume that they work because that's how we feel about the behavior, right? Another way that we can do testing is with formal methods. So this involves a lot of mathematics and linear logic. So anybody able to read this? Anyone? No one's worked with this? Yeah, me neither. I have no idea what this is, so we just kind of want to avoid this. There also aren't a lot of built-in tools for these kinds of things, so you're not going to have a very easy time doing formal methods. So the question is there some sort of middle ground? Because with formal testing, we can actually prove that our function works for pretty much any input-output combination. And the answer is obviously yes, or I would not have you at this presentation tonight. So we can do property testing. Just as a little disclaimer, there's still a little bit of math involved, but it's not going to be nearly as hideous as what we just looked at. It requires a bit more creativity because we're not just going to be thinking about specific input-output pairs, but we're going to be thinking about the actual behavior or the properties of our algorithm or our function and how we can test that. It's probabilistic in nature, and what I mean by this is if we have, let's say, 1,000 possible input-output combinations and we test 5 of them with unit tests, we have maybe a 5% confidence level that this thing is working. If we could do it for all 1,000 possible input-output combinations, then we can say we have 100% certainty that our function is working. There's also good support in automation, which you'll find in each language. I'll show you that a bit later. And it scales very well. If you have the resources to run tens of thousands or millions of tests, you can absolutely do that. Or you can make your number of tests that you run very small. But how does this work? Because I'm talking pretty abstract right now. So let's learn by an example. How many of you guys know what fuzzing is or smoke testing? So most people in the room, but for those who don't, fuzzing is actually a form of property testing. It's probably the simplest one to understand, which is that if I have a function and something goes in of some type, if I throw any value in for that, the function should not unexpectedly panic. That's basically the idea of fuzz testing. So does anyone not know what a palindrome is? Palindrome? Everyone? Okay, cool. So if we had a function called isPalindrome, and it takes a string as a parameter. We don't want to feed it some string and have it suddenly break, right? It's supposed to return true or false. So that would be our unexpected behavior, and we want to verify that the property, that for any string, that this thing will not break. But this is pretty limited because we're not really testing if our function works properly, like if the implementation is correct. We're just testing whether or not it's breaking. So what we really want to be able to do is define some properties about our function. And a property is just a true statement about input-output pairs. So again, let's learn by example. And I'm going to ask anybody brave if you can think of a property of an input-output pair, or a group, I should say, of isPalindrome. Just try to come up with one. So it's a true statement about an input-output. Anybody? You want to try?
Well, I don't know if it's a property, but the first letter and the last letter of the input have to be the same, and then it's true or something?
Yeah, so a palindrome is where you have the string reads the same whether it's forward or backwards, right? But to be very clear about this is actually very easy because we have a bool as our output, right? So there's only a binary thing that we can get back, true or false. So we can literally say that one of our properties is that for any palindrome that we throw in here, it should return true. And the opposite property would be for any palindrome that we throw in here, it should return false. And those are pretty simple properties to understand, which is good because it also makes it easy for us to write. So now how do we test this property? Well, first of all, we need a generator, or what we might call a strategy, to come up with all of these palindromes. So again, we're hoping for complete in terms of covering all of these inputs and outputs and correct. So here's an idea that I just put together. Let's generate a bunch of random strings, and then we'll make a copy of it. We'll reverse it, append it to the original string. And so, for example, if we had dag as a string, we'd make a copy and reverse it, so we'd have a gad. We'd append them together and we'd get dagad, and that's now a palindrome. Am I a genius, or does somebody have something wrong with this at all? How about an empty string? Okay, yeah, that's definitely something we should probably be checking. Just a spoiler alert, you can probably generate an empty string, so that'd be okay.
How do you generate words that are not palindrome? Just for the negative cases?
Okay, you're talking about negative cases. We'll talk about that in just 1 second. So let's think there's one more scenario we're not covering. Yes? We don't have the case where there's an odd number of characters. Very good. So we might have something where there could be like a Q or an R inserted in between these, and it's still going to work. So cool. So for a generator for that, we can basically do the same thing, but insert some random character in the middle. Make sense? Everybody cool? Awesome. Okay, so now somebody brought up the false case. How can we generate something that's not a palindrome? Anybody have an idea? Yes? Go ahead with the idea.
My idea was you take a string and you just copy it twice, but the string needs not to be a palindrome.
Mm-hmm. Yeah, so the idea is that you would just like take a string, append the same string to it, and it would probably not be a palindrome most of the time, right?
Yeah, but it's not.
Right, so a couple things like we're probably not going to have complete coverage of everything that's not a palindrome, and then also we might occasionally accidentally generate a palindrome. Like if we had the word dad and then we append dad to it, it's still going to be a palindrome. So how can we do it without?
Just do the same but previous one.
Make sure you don't have any repeating. Make sure you don't have any repeating letters, and then you can do that.
Make sure you don't have any repeating letters. Okay, that's also an interesting idea. Is that complete though? In terms of will we be able to get all things that are non-palindromes out of that? Probably not. And just as a simple one would be like DD, A, and that's it, right? We've got repeating characters. Yes?
Generate palindrome, but just read this one letter.
Generate a palindrome and remove a letter. Also a good idea, but probably not complete. So I have a suggestion. Somebody tell me if this is a good or a bad idea. We generate a string. We generate, we make a copy of it and flip it. And we do what we did before and we append it. And if it's a palindrome, then we just discard it. And if it's not a palindrome, we move forward. Is there a problem?
You're using the same properties that you want to test to generate the test case.
Yeah, so we've snuck in something, which is that we've basically required our implementation to work in order for us to test, right? So what about this? Okay, we'll generate a random string, we'll make a copy of it and reverse it, and if the strings match, we'll discard the test case, and if they don't match, we'll append them and send it to our function. Can anyone think of a counterpoint? I'm just curious.
You have the case where it's a
Where it's odd. Where it's odd. Very good. Okay. So we'll also do the same thing, but we'll just insert a random character in there. Any counterexamples? Okay. I think this one should work.
I guess there's the trivial example of length 1, which is always a palindrome.
Length 1, yeah. So there are going to be a couple of edge cases that we still have to think about, just like we would with unit testing. So definitely there might be a case where we just want to generate one thing. We have to think about that too. But overall, this is kind of the idea. So there's still kind of one problem though, which is that if we just use some random rand library out of your favorite programming language like Rust, then the computer comes back and it says, hey, this 10,000 character string just failed a test. Here you go. Here's the 10,000 character string for your review. Is that helpful? Not really. That's going to make our testing just as laborious as it was before, and probably quite a bit more annoying. So whenever we talk about property testing, we have the idea of shrinking, which is basically trying to get the computer to make the smallest reproducible case where it can fail the test, and it can say, hey, here's this 3-character string that failed, or this 4-character string, instead of feeding us something huge. And just as a simple example of how this could work for like an integer, if you wanted to get down smaller, anybody know what a binary search is? Yeah, I'm seeing a lot of hands. So we keep track of our minimum value, our maximum value, and some mid value. This is like the current value that we're testing. If it passes, then we try to do a higher value, right? And then eventually we find something that fails, and then we work our way backwards to try to find the smallest thing that failed. Now this is pretty trivial because it's integers. There are more complex strategies for doing this with strings, but the general overarching idea is the same, that we want to get these things to be smaller so that they're easier to review. We'll take a look at an actual example of that in a little bit. So now let's think about something that is probably more useful for you and something that you might have to use regardless of what type of applications you're developing, which is a stack. Everybody familiar with stacks? Okay, got a lot more on that, but just for a little reminder, it's an abstract data type, which just means that it can be defined mathematically. And it's, to put it in simpler terms, it's a collection of elements. And the only way to change its state are with these two operations: push value onto the stack and pop a value off of the stack. Usually it's going to have an isEmpty implementation as well as some peaks so that you can check the top value that's on the stack without actually popping it off. So can anybody think of some properties of a stack?
First in, last out.
Say that again.
First in, last out.
First in, last out. Yes, or it's often said last in, first out. Yes, exactly. That's definitely something we could say as a property. Can somebody say that in a way that has to do with like inputs and outputs or the behavior of the stack? What's something we could test? Yes.
If you take x and you do push on pop, you should get the same value.
Very good. Yeah. So if we have a stack and it's empty and we push some value x onto it, the next value that we pop off should be x, right? So that is one property of a stack. Any others? Anyone think of something a little more difficult?
If you push n items and pop n items, the stack will be empty.
If you push in items and pop in items, the stack will be empty. Yeah, that's definitely a property. Yes?
If you push a list of items, you should get a reverse list.
Very good. Yeah, if you push a list of items on and you pop them all off, you should get them in reverse order. So, very good. You're a super genius back here. So yeah, it is last in, first out. And this is how we would say this in a little bit more of like a math syntax, right? If we push x onto the stack, and we pop S into V, it should be equivalent to saying X goes into V. And then the second, like he just said, if you push 1, 2, 3, 4, 5 in, doing 5 pops should yield 5, 4, 3, 2, 1 respectively. Here's another one. A new stack should be empty, and once the value is pushed, it should be non-empty. And there's one more that we'll talk about in the code. But a lot of different coding languages have property-based testing packages, crates, libraries, whatever you'd like to call them. We're going to be working with one called prop test from Rust. These all kind of derive or trace back to QuickCheck, which was written in Haskell. And yeah, whatever language you use, I think you won't be restricted, at least with any modern language. So a couple things that we're going to be looking at and using. I just want to quickly cover, there's a prop test macro that's doing a bunch of stuff under the hood. Those can be things like the shrinking we talked about earlier and giving you that functionality without you actually having to write it. And we do this just like normal testing where we use our little test identifier. We have our function. And then here's a handy generator that prop test has built in, which is when we use this dot dot notation, specify our range of values and the type of value that we want. It will actually use that to generate random integers, for example. And then we can just do our tests like normal, run it on our function against some condition, and do our assertions. So there's a few other tools that are really useful. They have collections that you can generate, so you can generate vecs of random size between, like in this example, I've said, hey, give me a vec that's between 0 and 10 elements, and the elements themselves are going to be between 0 and 100, and it's going to generate a whole bunch of these things, random sizes, random numbers inside. You can have hash maps. There is also a handy thing where you can actually define a strategy yourself by making a function that returns a strategy with whatever type of value you want. So in this example, I'm just passing in a vector. And because of the way that prop test works, everything that prop test is going to work with is going to be a strategy. So I can't just tell this thing that I want to shuffle nums, or it's not going to be able to shrink this thing back down. So I'm using this little gist wrapper, which tells prop test that I want to yield this thing like over and over again exactly the same, and that is my strategy, and then calling another strategy that they have called prop shuffle, and that will return me like a shuffled list, for example. I've linked docs and also some of the examples that I'm going to show derive from some stuff Mate wrote a while ago, so I've got his GitHub in here as well. So let's take a look at some code. All right, and here we go. Okay, so first of all, I have my stack implementation. I'm kind of hiding the implementation details because it doesn't really matter for the purposes of this example, but we have something to create the stack. We have a pop operation, which will pop an element off, push operation, is empty and peak, as discussed earlier. When you work with prop test, like I said, you're going to be using the same test structure that you normally would in Rust. So you can have your config test, run mod tests, and then you're typically going to include this prop test prelude, which will just basically bring in everything that it has to offer. So first test that I'm running here as a property is actually just a unit test. So there's nothing about prop test in here, but I just have a simple test for if the stack is empty. I'm just going to go over that for now because it's not really going to be useful. So when you have your prop test macro defined inside of your tests, you can use a config, so you can tell it how many cases you actually want to run. So in this case, we're going to run 1,000 tests for each of these tests that I have implemented. So the first test idea that you came up with, the first property, was that if we create a stack and we push a value on, that we should get that same value off when we pop it. And so I'm using, again, this generator for random numbers between 0 and 1,000. Shouldn't matter what I push to the stack, we should get the same number that was generated back. So this is a little more of a complicated property, and it kind of ties into the reversing situation. But another property is that if we have a stack that already has values populated in it, and let's say it comes into our function at some point, when we push a value on and pop it off, the original stack should still be there and it should be unaltered. So for this one, I'm using a couple more tools from the toolkit. So for example, in this case, I'm using num i32any. So there are a number of handy kind of like side generation items that you can use from different collections and different base types that Rust has implemented. So that'll pull any i32 out. And then I'm also doing this interesting thing where I've written my own function called arbstack, where I'm saying I want to have 10 elements in that stack, at maximum of 10 elements in that stack that I'm going to test against. And so, like I said earlier, you can actually generate your own strategies. So here's what this looks like. I have an arbstack function that takes a max size, and it's going to return stack as a strategy, which is the stack implementation that I made. We have prop tests. I'm using the vec to generate just a random list, like we talked about before, from 0 to max size. And then using prop mapping. Is everybody familiar with functional programming? Yes. Oh, sorry. That better? Okay. Is everybody familiar with maps, like functional programming? Anybody not? Really, everyone? Okay, that's awesome. Okay, so prop test has its own map built in so that you can do things like mapping and flat mapping so that you can actually nest these strategies. So in this case, I'm doing the prop shuffle on this vector. I get the vector out. I'm yielding the vector, and then creating a stack, pushing all of these items on, and then returning that randomly generated stack, right? So going back to the test here, where is this? Here it is. So I immediately make a clone of this stack. I push these elements on. I push this element on, I pop the element off and make sure that it is the value I expect, and then I just make sure that that original stack is as it was before. Reverses elements, very similar. So again, using this prop test collection vec to generate these random vectors of random sizes, and creating a new stack for all of the numbers that are in that vector, pushing them on, getting a reversed version by popping all of the elements off, or what should be a reversed version, right, and collecting those, and then asserting that stack.pop is none. So somebody said that a stack should be empty after we do this, right? And then at the end, asserting that the reversed items that I pulled off of the stack are actually the same as the reversed items of the original vector that I generated. Cool? Awesome. And then the last one is just testing non-empty after push. I probably don't have to make this a separate test, but if this was a specific behavior you wanted to test, then this one is quite simple, and I don't think it covers anything that we haven't already. So let's run this thing, and I'll show you what this does. Whoops. And I guess I should clear so you can't see all of the excitement already. So just like normal, we run cargo test. And in 0.08 seconds, we just ran 5,000 tests. And now we know that our stack implementation is actually a stack. You guys seem way less excited than I thought you'd be. Okay, so this wouldn't be very interesting if we didn't try to also show how this could break. So now we get to see my super secret implementation down here, where I'm using a vec deck. So at the moment, I'm popping to the front of this thing and pushing to the front, so that is stack behavior. But if I change this, sorry, One more. Let's just change this so I push to the back. And then we'll run these tests again. Oh, here we go. Oops, I can't see my mouse. There we go. Oh, hang on one second. So I completely broke this thing, I think. One sec. Whoops. Maybe my working example was doing the pop. One second. Okay. Okay, so anyway. What we have is it has panicked at some assertion, and it shows me what the left was, and it shows me what the right was, and then it says the minimal failing test case it was able to produce is this. And if we scroll up, we can see that these get more and more complicated as we go up, both in terms of the length of the array, but also in terms of what these things actually contain per element. Cool. Questions from you guys? Yes?
Do you recommend combining property-based testing with fast testing or?
Compile with fast testing?
Combine.
Sorry, one more
Do
time?
you recommend combine this with cargo fast or?
That's an interesting question. I actually have not tried. So I'm not sure how to answer that other than to say you might want to check online to see if they support it or not. Yeah. But chances are it may be integrated. So, yeah. Other questions? Anybody have a problem they're curious about how you would property test? Getting some input? Yeah.
Yeah, so for like the palindrome example, you'd presumably want to make sure that you have the empty string test. Is there like anything you could do with property testing like this where you would make sure you actually have these edge cases?
Yeah, so the question is like when you have edge cases, so in the is palindrome example, you might have a case where you just have an empty string and you want to deal with that. And the question is, can you do that with property testing? The answer is yes, but you probably don't need to write it in something like prop test. You can just write it as a unit test, but it is technically a property, right? So that's more of an abstract idea versus like how you implement it. Okay. Other questions? Yeah.
Are there any cases where prop testing is not useful or cannot be used?
That's a really good question. Is there any situation where prop testing is not useful or can't be used? The answer is yes. And there also may be situations where it's just more time consuming, depending on what you're trying to do. Mate might have some good ideas on things that you can't do in property testing. Yeah, and one thing that's important to remember too is the thing that we're saying property testing is, let's say, better for is to try and cover completeness of your algorithm, right? But this is assuming that you are running these things in a, setting your option for the number of tests that you're running high enough that you're actually covering that completeness. So just one simple example is that if you're not going to run this thing on a large space of inputs, it's not as meaningful, right? But I think, oh, here it comes. Mate may have some good examples because he's worked with this for longer than I have.
Can you all hear me? Yeah, to answer Brian's question. One thing that is very difficult to do is there are some ways that you would want to combine generators, aka strategies, to get the type of inputs that your thing needs that often you just simply can't do because of limitations of the framework that you're using. We actually bumped into this while using prop test, this specific framework that Sean is showing. Another thing, I would say if the component that you're testing is really simple, so the input space is small, and if you can exhaust that manually, you're probably better off doing that. Like let's say your function takes 5 possible inputs, it does stuff, then you're very likely better off just having 5 unit tests for those simple cases. But I would say most things that you would have in a program are not like that.
And just to piggyback on that, there are also situations where when you actually end up writing the test, it may get complicated enough that you're no longer certain if your generator, for example, is reliable. So if you're doing really complex problems, maybe things that most people won't touch here, but like graph problems, for example, there are some situations where these can get really difficult to even think of how to organize those property tests, and the more and more disorganized your testing gets, the less certain you are that your algorithm is actually doing what you think it is. So, yeah.
Do we have opinions on Burnt Sushi's quick check versus prop test?
Burnt Sushi's quick check for Rust, is that correct?
Yeah.
Yeah, there's actually a write-up on prop test documentation, or the introduction to prop test, about the trade-offs between the two. If I'm correct, quick check is not really supported at this point, and I think the person actually had a discussion with them in a GitHub issue, which pretty much left as prop test is generally more useful. However, it will be a bit slower because the quick check, if I remember correctly, has some specific limitations in terms of how you can make generators that also make it so that everything is pre-sized or pre-type checked ahead of time in a way that you can't do in prop test. But for the specifics on that, I'd suggest reading the introduction.
I hope I'm not making this up, but if I remember correctly, one major difference between prop test and quick check is in quick check, you can only have one strategy, aka generator per type. Whereas in prop test, you can have arbitrarily many different generators for the same type. So if, as an example, if you want to have one strategy that is generating even numbers and another strategy that is generating odd numbers, then it is easy to do and quite straightforward. In prop test, you just add 2 of these like function-like things that will be strategies. If you want to do this with quick check, then you have to first split the type. So basically introduce 2 new types, one for even, the other one for odd, and then you can write your generators attached to them. That was like a major difference that stood out to me. Yeah.
My question was a little bit answered already.
Mm-hmm.
I was wondering, comparing between unit test and property test, what is the main differences or strength that is trying to address? But I guess it's the completeness because of the generator and the probabilistic approach to generate test cases.
That's right. So the question is, what is the primary benefit of doing property testing over unit testing? The completeness of your checking is definitely a major benefit. It has the same weakness as unit testing, though, which is that if you don't think of all of the situations that can happen, then you'll have property-based tests that are incomplete. So the reason that I prefer it, even in these types of situations, is that it's really fun to think about how to implement them, whereas for unit tests, it's usually not. So yeah.
Sorry, one more. You also mentioned maybe a little bit of math might be necessary.
Mm-hmm.
Is there anything specific to property test where you have to do some formula building or math thinking?
Yes. I actually had to do something recently that used some math, and I had to read like a research paper on how something worked. But it was fairly simple, so it's not like you're not going to need to know tons of like calculus or something in order to do this. Do you have any examples like specifically where you need to use math?
Actually, if I understood your question correctly, you're asking whether is there specific math for property-based testing in general that you have to learn, and the answer is, I would say no. Sometimes you have to learn more about the input space of your objects. So if you have mathematical structures as your input, like let's say graphs or meshes, these sort of things, then you'll have to think about those more deeply than if you're just assembling test cases by hand. So what's a good example? Like, let's say you are testing a function that is supposed to work on symmetrical matrices. You can always just construct symmetrical matrices by hand, but then if you have to generate these, then you really need to have a deeper understanding of, okay, what is a symmetrical matrix, right? This sort of stuff. But I don't really find this to be a burden when I'm doing property-based testing. Yes?
Yeah, so what's the best way to determine the number of iterations you want to do? Do you calculate some sort of confidence threshold, or just pick a big number and call it?
That's a great question. I don't have a good answer. You can always think about, like, try to estimate how big your input space is, and then decide based on that. But sometimes the input space is infinitely large. Let's say you're testing, your input is a JSON object that can be like an arbitrarily deep tree, right? So you can't exhaustively generate every JSON tree that might possibly exist, but if you're testing with a large variety of random trees and your tests are passing, your implementation is way more likely to be correct than just having tested it with 5 large JSON trees and that's it. Right, so it's I basically, this is a long-winded answer saying that there's no fast and hard rule on how many of these iterations to do, but you do have to tune it, and often tuning it comes down to what is the latency that you're willing to tolerate when you're running this in CI, for example, because if your test suite takes 2 hours to run, your developers are going to be angry, and that's probably less bad than not having tested things with a shit ton of cases. Yes?
So I was kind of wondering how the minimum test case example works. Like one thing that bothered me about your example is, like, I think it outputted a stack with like 8 or so items, and presumably when you replace push front with push back, you could just have a failing test case with length 2, right? Mm-hmm. So is it like it just like spits out something that's, you know, short enough for a human to understand, or is that just like a limitation of the framework? Or?
No, it's actually really funny because when I ran this example earlier today, I got back a like 2-element thing. I have no idea what just happened, and I would have to sit down and like review. It might have been that a different test that I added after may have broke, and I had run it beforehand. So that's just my bad. But usually the results that I get are very small and very easy to parse. I have no idea what just happened there, but yeah. I might have set the minimum vex size on one of the examples to like 10 or something, so.
All right, we're almost out of time, and I want to move on doing my thing that I usually do, which is ask the presenter how they started learning Rust. What was your inspiration?
Getting hired at Braid.
That's the only correct answer, but seriously though.
I got interested in Rust almost by chance. Anytime I see some new technology or something, I kind of want to check it out. I dive through a number of different coding languages, from like C to C++ to Java to JavaScript to Python to Go, and Rust, just to address some like concerns in terms of writing code that sounded really interesting to me, which I'm sure you're all familiar with like memory protection and everything. And I was just very curious to learn how Rust works, and I'm glad I did. And then getting hired at Braid was a big motivator for me to like kick it into gear. So.
What would you say was your strongest language before you started learning Rust?
Probably Python or Go, but that kind of changed over time just based on how often I was working with the language for like my job or projects that I was working on. But I definitely felt really comfortable in Go right before I transitioned, and now I feel like I've already forgotten all of Go.
So coming from Go and Python, what were some things that you found particularly difficult to understand and learn to use?
Quite a few things. The general borrow system was very confusing at first, primarily because probably all of the C code that I wrote was horribly broken and I had no idea. And now that I understand the borrow system, it makes a lot more sense, but that was definitely a big hurdle to get over. Other things, originally when I was looking at like the difference between all of the like traits and everything else that Rust has to offer, had quite a few more tools than like I have to think about most of the time in Python or Go with what I'm writing. So just getting a handle on all of the different like powerful things you can work with, and also functional programming, which I'd worked a little bit with like list comprehensions, for example, in Python, but definitely the whole functional programming world was really cool to get into. At first it made no sense, and then once I understood it, it was like a big breakthrough. So.
And what was something that you really liked about the experience of using Rust?
I think the first time I got functional programming felt really good, and then once I started to like think functionally, that was very enjoyable, because you can program functionally in a lot of languages, but you're not really incentivized to in a lot of them, because they're not necessarily like better for your solution. I think that Rust is really good about having the right types of tools that you would want to use in pretty much every situation that you would need to write functional programming, and especially with like the enum system. Yeah, I would say that was probably the two things, like the enum system and then also the functional.
Gotcha. Just one more question. This is my favorite one that you all love too. What would you like the next presenter to talk about? What's a topic that you really want to learn about?
I think it'd be really cool if somebody like did some coverage on like game dev or something, but I don't know. It's not a lot of tools for that yet.
That's a great idea. I love game dev too. So if anybody here wants to talk about game dev, please shoot a message to me. This is the bottleneck, finding presenters, good topics that people want to learn about. That's the sweet spot. Anyway, the food is here, so thank you for the great presentation.
Thank you.
Thank you for coming. Just one more thing. Like I said, we will have community announcements going forward. So if you have some sort of an announcement, like the company you work for is hiring Rust developers, or you're hosting a Rust hackathon, I don't know, something like that, then just let me know, and next time you can come up here, grab the mic, and tell people about this great thing. All right. Yes?
There's beer for 10 more minutes.
That's right. It's good thinking. I like it. So the beer is going to stop at 8. So you might want to start by grabbing beer and then grabbing pizza. And we also kind of need to be out of here by 8:30. Like we need to return this area. But